What if the slowest process on Earth could be compressed into 7 hours? Right now, across the Sahara, sand is winning. But scientists in Norway have built something strange. A liquid that turns barren dune into living ground before the sun sets. In the next 20 minutes, you'll see how and why the clock's running out. The Sahara is not standing still. Every year, this desert creeps further into land that used to grow food, pushing families and farms south, ahead of a slow, grinding collapse. Governments have tried to stop it the old way. Dig a hole, plant a tree, hope it survives. It rarely does. Sand simply cannot hold water long enough for a seedling to survive its first summer. So in 2017, a small Norwegian company proposed something almost absurd. What if you didn't need trees first? What if you could fix the sand itself? This is the story of Liquid NanoClay and the race to green the world's harshest desert before it's too late. To understand why this matters, you have to understand what desertification actually is. It's not the desert marching in like a wall of sand. That's the movie version. The real process is quieter and worse. Soil loses its structure. Nutrients wash away. And land that once fed people simply stops being able to. Across the Sahel, the strip of land just south of the Sahara, this isn't an abstract statistic. It's the reason farmers become refugees. Which is why, back in 2007, African leaders proposed something enormous. A wall, not of concrete, but of trees, stretching the width of a continent. They called it the Great Green Wall. The plan was staggering in scope. 8,000 kilometers of restored land, cutting across 11 countries, from Senegal to Djibouti. The goal: restore 100 million hectares and create 10 million jobs, all by 2030. Nearly 2 decades later, the wall is roughly 30% built, according to the UNCCD's 2025 progress report. Real progress. But the funding tells a harder story. Of the $33 billion needed, only a fraction has actually arrived. At this pace, the wall won't be finished on time. Which raises an uncomfortable question. Even with unlimited money, is planting trees, one at a time, ever going to be fast enough? Sand doesn't hold water. A young tree can die of thirst in days. Restoring soil naturally takes nature 7 to 15 years. The Sahel doesn't have 15 years. So a Norwegian engineer named Christian Olesen asked a different question. Instead of waiting for nature to build soil, what if you could manufacture the effect instantly? After 8 years of research, he had an answer. He called it Liquid NanoClay. The idea sounds too simple. Break ordinary clay into particles a nanometer thick and suspend them in water. Spray that onto sand, and something strange happens. The clay doesn't just sit on top. It sinks, wrapping itself around every single grain of sand it touches. In 2017, Oleson's research became a company, Desert Control. Their claim: soil formation in 7 hours, not 7 years. That number, 7 hours, sounds like marketing. So we're going to take it apart, piece by piece. The chemistry, the results, and what the press releases leave out. Because if this works at scale, it doesn't just green a few farms. It rewrites what's possible for every degraded landscape on Earth. But if it doesn't, if it can't survive contact with a real desert, then the Sahara keeps winning. Here's what's actually happening. When that liquid hits the sand, start with the sand itself. Desert sand is almost pure silica. Hard, round grains with almost no ability to hold onto water or nutrients. Rain falls, and within minutes, it drains straight through, as if the ground were a sieve. Clay is the opposite. Its particles are flat and charged, and they cling to water molecules like a magnet. Normally, mixing clay directly into sand clumps into hard, useless lumps. Desert Control's process avoids that, breaking the clay into nanoscale sheets that gravity carries deep into the ground, coating individual grains instead of clumping on the surface. The coating itself is astonishingly thin, 1.5 nanometers. To put that in perspective, if a grain of sand were the size of a football stadium, that clay layer would be thinner than a coat of paint. But that thin layer changes everything. Coated sand behaves less like sand and more like loam. The rich soil farmers spend generations building. Water that once drained away in minutes now lingers, held by the clay's electric charge, available to plant roots for weeks longer. Engineers have a name for what this creates: a subsurface sponge, a hidden reservoir just beneath the surface, built not over centuries, but over a single afternoon. Here's what that afternoon actually looks like. Desert Control mixes their NanoClay concentrate into a farm's existing irrigation water. No new infrastructure required. The liquid spreads across the sand, and gravity pulls the clay particles into the soil profile below. Desert Control states the process fully saturates the land in around 7 hours. Compare that to the natural root, wind and root slowly building soil structure over 7 to 15 years. 7 hours, 15 years. That gap is the entire premise of this technology. So does it actually work in the field? According to Desert Control's own data, treated land produced yields roughly 4 times greater than untreated desert soil, using the same seeds and fertilizer. Water use dropped by more than half, and harvest windows extended by 2 months. Each treatment, they say, lasts up to 5 years. The cost, right now, sits around $2 per square meter. Expensive at small scale, but scaling up production could push that down to roughly 20 cents. A tenth of the price. If that's true, this stops being a novelty. It becomes infrastructure. This is where the story connects back to the wall. Desert Control has partnered with the UNCCD, the body coordinating the Great Green Wall, to pilot Liquid NanoClay across North Africa and the Sahel. The logic: instead of years preparing soil, treat the sand first, then plant into ground that holds water. It's not a replacement for the Great Green Wall. It's a shortcut, compressing the slowest phase of restoration into a single afternoon. But partnerships and pilot projects are not the same thing as 100 million hectares. And that gap between promise and scale is where this story gets uncomfortable. Because here's the part rarely mentioned. Most of the data behind these numbers, the 4 times yield, the 7-hour saturation, the 5-year durability, comes from Desert Control itself. Independent, long-term field studies at real continental scale are still limited. That doesn't mean the technology is fake. Multiple pilot sites, from Dubai to Egypt to Morocco, have shown promising, verifiable results. But there's a difference between this works on a test plot and this can green a desert the size of the United States. So let's look at both sides. The believers and the skeptics. The case for optimism starts with speed. Climate-driven desertification isn't slow motion anymore. The Sahel faces rising temperatures faster than the global average. Every year spent waiting is a year of lost harvests and displaced families. Liquid NanoClay, if it scales, offers something almost nothing else in this fight does. Speed measured in hours, not decades. Advocates argue that pairing it with the Great Green Wall's tree planting effort could dramatically raise survival rates for new seedlings, giving roots something to hold onto before the sun and wind kill them. For farmers on the front line of desertification, that difference between hope and failure can be measured in a single growing season. Now the skeptics. First, logistics. Transporting enough concentrate to treat millions of hectares across remote regions hasn't been tested at that scale. Second, dependency. This runs through one company, raising questions about cost, access, and what happens if it can't keep up. Third, durability. 5 years sounds impressive, but deserts don't stay still. Wind, heat, and flash floods could erode treated layers faster than lab conditions predict. None of these problems are disqualifying, but they are real. And then there's money. The same problem already slowing the Great Green Wall itself. Even at 20 cents per square meter, treating 1 million hectares would cost roughly $20 million. The Great Green Wall's own funding gap, billions still unfulfilled, shows how hard it is to turn a good idea into a continent-scale program. Liquid NanoClay doesn't solve that funding problem, At best, it makes every dollar that arrives go further. Technology alone has never been the missing piece here. Money, political will, and coordination across 11 different governments. That's the harder puzzle. Step back, and the stakes come into focus. International agencies have warned that without intervention, desertification across the Sahara could displace a significant share of the region's population in the coming decades, becoming one of the largest drivers of climate migration on the planet. This isn't an abstract environmental story. It's a story about where people will be able to live, grow food, and raise families 20 years from now. Every technology in this fight, trees, nanoclay, irrigation networks, is, in the end, a race against a timeline that doesn't care how clever our solutions are. So where does that leave liquid nanoclay? Not as a miracle, not as a myth. Somewhere in between. A genuinely promising tool, still early in its journey from lab result to continental infrastructure. The 7-hour number is real, recorded under specific conditions. The 4 times yield is real in the trials run so far. What's still unproven is whether it holds up at the scale the Sahara demands. The technology has done its part. It proved the concept. Now it's waiting on everything else to catch up. Zoom out, and this story stops being about one company or one clever chemical trick. It's about an older question. Can humanity out-engineer timelines? Nature was never built to rush. We've done it before. In medicine, agriculture, energy. Sometimes the shortcut breaks in ways nobody predicted. The Sahara will not wait for a clean answer. Every year without action, more land crosses from struggling to unusable. Liquid nanoclay won't single-handedly finish the Great Green Wall. Nothing will, on its own. But it might just buy the one thing this fight has never had enough of: time. Picture the Sahara in 2040. In one version, the wall stands unfinished. Funding stalled. Sand still winning. In another, a strip of green, imperfect, still expanding, cuts across 11 countries, built one treated hectare at a time. Which version becomes real won't be decided in a lab in Norway. It'll be decided by whether the rest of the world treats a fast, unproven technology with urgency, or lets it become another good idea that arrived too late. The chemistry already works. The only question left is whether we do. If this kind of story, where science, geopolitics, and a ticking clock collide, is exactly what you come here for, subscribe to TrendX Versco. Catch the pulse. Lead the future. Next week, we're going underground, into the race to build machines that can mine the deep ocean floor faster than anyone can regulate them. It's a story with its own uncomfortable numbers and its own countdown. Thanks for watching All Tea.